So really, ladies and gentlemen, when you're writing the equations, you really want to find your A, B, C's, and D values. Because remember, in the equation, we're trying to write the equations in the form of y is equal to A. This could be a sine or cosine B times x minus c plus d. So we have to find the A, B, C's, and D's. Again, this sine may also be a cosine curve. There is what makes these equations a lot different than your algebraic equations. There is an infinite number of equations that you can come up with for one trig graph. Based upon the period, because these are cyclical, based upon where you're looking at where you want to start the cycle, you could take every sine curve and come up with a cosine equation, or vice versa. So there's an infinite number of equations, so it makes this a little bit different than what you've done in the algebra in the past. So first of all, to write these equations, you want to find your D value. We know that this is the vertical shift. And the way you identify the D value, this is going to be the midpoint between the max and the min. So the baseline, which is what we've been referring to as the D value, we know is the vertical shift. To figure out whether or not your graph has a vertical shift, identify the maximum point, identify the midpoint, and then identify the highest, identify the lowest, and then find the midpoint. That's what it's going to be. So for example, if you take a look at this first curve, notice your highest point is up here at 1. Your lowest point is down here at -1. So notice the midpoint between 1 and -1 is 0. So therefore, that particular graph would have a D value equal to 0. So that's how you identify whether or not you have a vertical shift. You look at the max, you look at the mid, and then you find the midpoint. The A value, this is your amplitude. So the way you find your A value, if you find that you count the number of units above your baseline. You could also do below. So once you identify the D value, identify the vertical shift, you find your amplitude by counting the number of units above or below the baseline. So for example, right here in this particular curve, I've noticed my maximum was at 1, my minimum was at -1. My D value is 0, so notice the distance between my baseline and the maximum, that is my amplitude. So I know that the amplitude would be equal to 1. Same thing right here. If you count the number of units below your baseline, that's your A value. So that's how you identify your A and your D value. So now remember, we have to identify the B value, which is related to the period. So again, the B value is found exactly very similar to the way we found the period. To find the period, remember, we took 2 pi and divided by the B value. Well, now to find your B value, and that's the value that goes in the equation, it's going to be 2 pi divided by the period. So once you identify, the way you look at your graph to identify the period, identify your 5 key points. Wherever that 5th point is located, the x-coordinate is the period. As long as there's no phase shift, which we're always going to start writing these equations with no phase shift first anyway. So you're going to identify your 5 key points. If it's a sine, we'll go base, max, base, min, base. Wherever that 5th baseline point is, look on your x-axis, and whatever the x-coordinate of that point is, that's going to tell you what your period is going to be. All right? Yes, Jen? It is the period. And in parentheses, as long as there's no phase shift. So, for example, right here, if you look at this particular graph, identify your 5 key points. Baseline, maximum, baseline, minimum, baseline. So whatever the x-coordinate right here is, that will tell you the period, which would be 2 pi because this is the parent function. All right? And then the C value is the phase shift. All right? And again, that's going to be the first point of the cycle and the distance from the x-coordinate. And then again, you always want to check for reflection. All right? As I mentioned a few minutes ago, because these equations are repetitive and the domain of sine of x is all real numbers, we can write the equation in many different ways. So for example, let's just practice before we start taking a look at the graphs. Let's write a sine function. So again, always identify whether we want a sine or a cosine. That satisfies the given information. We have a period of pi, amplitude of 4, and vertical translation of 5. Remember, writing the equations in the form of y is equal to a times the sine of bx plus d. Since there's no phase shift, I don't have a c value here. So I need to find my a, b, and d values and plug them in. There's no c since they did not tell me I have a phase shift. So looking at the information they're giving me, what is my a value going to be? My a value will be 4. My d value will be 5. So now remember, the b value is found by taking 2 pi and dividing it by the period. So what are they telling me my period is? My period is what? Pi. So then what's my b value going to be? 2. So now I plug them into this equation. So y is equal to 4 times the sine of 2x plus 5. So there is the equation. So any questions? Again, the big thing is, guys, remember, it's not the period that's in the equation. You have to find the b value. All right, so any questions on how, given this information, you can write the sine function? All right, so here's another one. Oh, yep, go ahead.
The b value, how'd you get the pi on the
Because they gave that to you. They told you the period is pi.
bottom?
Okay? Period is pi.
I thought when they do a period equals pi, like we're supposed to find out what it equals.
So now remember, we're going in reverse now. So again, before I was giving you the graphs and you were graphing and I was asking you to tell me what the period is. Now it's you have to know the period to find the b value because we're writing the equations. Okay? So now let's take a look at b. So I'm telling you the period of pi over 2, amplitude of 3, and a phase shift of pi over 3. So again, it's still a sine function, so y is equal to a times the sine. Again, remember, when there's a phase shift, you want to make sure that that b value is factored out of the parentheses. So now what's your a value going to be? A will be equal to what? 3. Again, c is my phase shift. So I'm going to go pi over 3, and again, if they wanted me to go to the left, they would indicate it. So we're going to go over pi over 3 to the right. Now, they're telling you we have a period of pi over 2. So my b value has to be 2 pi divided by pi over 2. Well, when I divide fractions, guys, remind me again, how do I do this? I'm going to multiply by the reciprocal. So it's going to be 2 pi times 2 over pi. So then what's the b value going to be? B is going to be equal to what? 4. So any questions on how I found A, C, and B? They did not give me a vertical shift. So there's no vertical shift in this one. So then I can write my equation. Y is equal to my A value, which is 3, times the sine of 4, times x minus pi over 3. Remember, if we're going to the right, it's a minus sign. So guys, the big thing I need to caution you about, when you have a phase shift and a period change, you want to make sure that your b value is factored out of the parentheses. You could distribute if you wanted to, but why make extra work for yourself? That I would not take off if you wrote the equation that looked like this, 4x minus 4 pi over 3. They are equivalent. But you don't have to distribute that 4 in there. But you have to, again, make sure that it is factored out when you're writing the equations. Yes, Jed?
When we get that type of stuff, is it always signed?
The directions just told me it was a sign. Okay, they would have to tell you, if I gave you this information, they'd have to tell you whether it's a sine or a cosine. But this case, the directions specifically said sine. Okay, but they very well could have said in the directions, write a cosine curve with the given characteristics. But you would do it exactly the same way. So any questions when giving you that information, how you can come up with the sign equations? Yes, Karis?
How did you know that the phase shift was to the left?
You mean to the right?
To the right, yeah.
They'd have to tell you specifically it was going to, they would tell you if it was going to go to the left. Any other questions on that? All right, so now let's talk about how we're given the graph. Like I said, there's multiple different equations that you could write for every single graph. So I'm giving you some specific information on how to write the equations. First of all, we always are going to write an equation with no phase shift. That's how you always start. So you always want to, first of all, write an equation with no phase shift. Remember, with no phase shift, that means your first key point has to be on the y-axis. You're starting at an x value of 0. So now, first of all, let's identify the d value. Well, your maximum is 2. Your minimum is 0. Remember, d has to be halfway between the max and the min. So where is the baseline going to be for this graph? 1. So I know I have a vertical shift of 1. So now, once I know my vertical shift, identify your amplitude. How many units above or below is the baseline for those max and min points? It's a distance of what? 1. So I know A is 1. So any questions on how I found the A or found the D? Now identify your 5 key points. The first point is on the baseline, correct? Then where's the next key point? It's going down to the minimum. Then it's going to the baseline, maximum, and then your baseline. So there is one full cycle. So now looking at this graph, is it a sine curve or is it a cosine? Sine. It's a sine. Why is it a sine and not a cosine? Because it's starting on the baseline, exactly. So everybody agree with me that this is a sine curve. So it is a sine curve. So now, what's the period? 2 pi. How did I know my period is 2 pi? That's the x-coordinate of the 5th point. So there's your period. That's why it's critical to write that first equation with no phase shift. So if my period is 2 pi, remember b is found by taking 2 pi and dividing my period. So what's my b value going to be? 1. Now, you told me it's a sine curve. But what's special about this sine curve? It's a reflection. So when I go to write this equation, remember I'm always writing it in the form of a sine or cosine b, x minus c plus d. So what do I have to put in front of my a value here? Because it's a reflected sign, I have to put a what? A negative. My a value is 1, so negative sine. B is a 1x plus 1. So there's the equation for the first equation with no phase shift. So the reason why you always want to start writing an equation with no phase shift, because the characteristics of the curves are going to be the same of the A, the B, and the D values with the phase shifts. So the A, B, and D values are not going to change with a phase shift. So the easiest way to identify the A, B, and D is when you have no phase shift. So now let's take a look at the second equation that I want to write. We want to write an equation with a phase shift, 1 key point shift to the right. So what that means is you've identified your 5 key points. So now what I want to do is start my next cycle at this key point right here, shifting it to the right. So this is a minimum, correct? So again, identify your 5 key points for this next curve. Minimum, baseline, maximum, baseline, minimum. So now what I want to do is I want to write an equation representing this part. This is what I mean by there's an infinite number of equations you can come up with for every single curve. Based upon your phase shifts, you can take every sine and write it as a cosine. Because if I do a phase shift pi over 2 to the right, and this is my first key point, what kind of equation is this going to be? It's no longer a sine, but it's a what? Cosine. And what's special about this cosine? It's a reflected cosine. So then my second possible equation I could come up with, the A value is still the same, the B value is still the same, the d value is still the same. So it could be negative cosine of x minus pi over 2 plus 1. There's a second possible equation you could come up with. Are there others? Absolutely. There's an infinite number of equations you could come up with. It all goes back to where are you looking at that first key point to be. I could come up with another equation if I wanted to look at this key point, looking at a phase shift pi to the right. So with the phase shifts, you can come up with an infinite number of equations. So any questions on those two possible equations? All right, let's take a look at number 3. So again, identify your maximum and your minimum. So what's your d value going to be? D will be equal to what? 0, because that's the midpoint. So again, I know that my d value is 0. So what's my a value going to be? A will be equal to what? 3. Again, because that's the distance above and below your baseline. So now let's talk about the period. So identify your 5 key points. The first equation I'm writing is with no phase shift. So the first point is going to start right there on the y-axis. What point is this, a max, base, or min? Base. And then where's it going to go? Min, and then it goes base, max, base. There's your 5th key point right there. So there is one cycle of this graph. So what's the period of this graph going to be? The period is what? 2. So then remember, the b value is going to be 2 pi divided by 2, or just simply pi. So looking at the pattern of your 5 key points, is this a sine or is this a cosine? Sine. And what's special about this sine curve? It's a reflected. So I can write my equation as y is equal to negative 3 times the sine of pi x. Again, there is no vertical shift. So any questions on how I wrote the first equation with no phase shift? Now let's take a look at the second equation with a phase shift. So again, so if I shift this graph off the y-axis to that particular point. So let's look at writing a graph using this first point as the first key point of the cycle. So this is a minimum. Baseline, maximum, baseline, minimum. What kind of curve is that going to be, a sine or a cosine? Cosine, but what's special about this cosine? Reflected. The question is, they didn't quite label every single coordinate along the x-axis for these 5 key points. But you can find it. What's the midpoint between 0 and 2? 1. So I know that this key point has an x-coordinate of 1. What's the x-coordinate of this point going to be? Well, what's the midpoint between 0 and 1? 1/2 or 0.5. So what's the phase shift going to be? The phase shift is going to be 1/2 to the right. So sometimes you may have to find the divisions along the x-axis yourself. So any questions on how I came up with 1/2? Again, the characteristics of the A, B, and D values are the same from the equation you wrote without the phase shift as it is with the phase shift. So you told me it's a reflected cosine, so it's going to be negative 3 cosine. Again, remember, leave that B value out, x minus 1/2. So any questions on how I came up with that second equation with a phase shift? Okay. All right, you guys go ahead and try doing 4A for me on your own. See if you can come up with the equation phase shift. What's it going to be? It's just pi. How do you know it's pi? Exactly. It's the midpoint between 0 and 2 pi. Exactly. Okay? What kind of equation is it going to be, a sine or a cosine? And again, you can check your answer when you're done. Again, make sure, guys, you have that b value on the outside of the parentheses. The other acceptable way you could write this equation would be 2 cosine of 1/2 x minus pi over 2. All right? There's no need to distribute the 1/2. I'm not requiring you to. Biggest mistake, guys, I see on tests and quizzes is students want to write this. Would that be an acceptable answer? No, that certainly is not equivalent to this one. This is probably the most common error I see. Make sure that you leave that b value factored out.
Well, I have a question.
Yeah.
Since the point gets extended inward, the last point go to 5 pi.
But the period's still 4 pi. Because again, the length of the cycle is going to go from pi to 5 pi. You're absolutely right.
Oh, okay.
But the period's still 4 pi.
Okay.
That's what I mean, like the A, B, and D values are going to stay the same, consistent throughout the equation. It all bases upon which point you're looking at. So, like, for example, if I start looking at the cycle at this point, a phase shift to the right 2 pi, I could come up with a reflected sine curve. That's why we have an infinite number of equations that you could come up with for one graph, which makes these a lot different than your algebraic graphs. Okay? But the period's still going to be the same. All right, you guys go ahead and try 5a for me. Come up with the equation with 2 cosine of x minus 3. Did we all come up with that? The a value of 2, b is 1, and then your d value is negative 3. Okay? Now you guys go ahead and come up with the second equation with no phase, with the phase shift 1 unit to the right. Again, so my second graph that I came up with, again, looking at a phase shift to the right pi over 4, so that's my c value. So it's now a baseline, maximum, baseline, minimum, and it goes to a baseline. So again, I'm looking at that particular curve and coming up with the equation. Yes, Jack?
I think plus 1.
Oh yeah, plus 1, 1, yeah, thank you. I forgot to put the 1. Yep. All right. So any questions on number 6? So any questions on writing the equations of sine and cosine? You guys go ahead and do the last one, number 7. Both of them. See if you can do the one with the phase shift. Should we come up with these as our answers? The second equation, again, turns out to be a reflected sine curve with a phase shift pi over 2 to the right.
Would they always reflect each other?
Usually if it's starts with a regular cosine, again, as long as you're looking at a phase shift to the right, then the second would be a reflected sine. I think we did an example. Yeah, usually they're reflections. Yeah, Mike.
So, for my phase shift, I got pi over 4. Is the point?
Well, you agree that the period's 2 pi, right?
Yeah.
So think about how I've had you do the divisions along the...
I just did it.
Yeah. Okay, easy enough question. Are we good on these? So any questions on how you can write the sine curve or cosine curve given a graph? All right. So, and that's it. So like I said, the homework, guys, for tonight is to do the 2.4 worksheet. All right. I'm sorry?